Hello everyone. This video is about example number 1 on sentence similarity pairs. The purpose of this is to show a similarity match between given inputs, in this case sentences. You will be providing the inputs, and after running the model, we will be given a similarity score between them. Our model will be taken from Hugging Face. Hugging Face is a collaboration platform between machine learning communities. Here you can find datasets, models, and much more available publicly for us. The one that we're interested in today is flax-sentencing-embedding, old dataset version 4 miniLM-L6. The real name for the model is miniLM-L6-H384-uncased. This one, they have a hosted interface API here for us to run an example. One of the examples provided by them is that our initial sentences is "this is a happy person." We are comparing it to other sentences such as "that is a happy dog," "that is a very happy person," "today is a sunny day." And after running compute, our model will run the similarity comparison between them. And after finishing, will give us this. "That is a happy dog" compared to "that is a happy person" has a similar point of 0.695, or in percentage 69.5% similarity. "That is a very happy person" however scores a much higher one, 0.943. This means that this one is 94%, so very similar to our original source sentence. We can clearly see that what they added here is just a very, instead of switching from a person to a dog, which indicates almost a 30% drop in score-wise. "Today is a sunny day." This, however, only gets a 0.257 score. So with this, you can experiment with a lot of your own sentences instead of just sticking to this. Both example 1 and example 2 will be using this model, old dataset version 4 miniLM-L6. And while the first one will be a pair comparison between every two sentences in our inputs, our second example will actually be comparing 7 sentences, almost all of the inputs, versus one of the sentences. And from there, we'll be able to rank them individually against one sentence at a time. Our first Jupyter Notebook sentence similarity pairs can recreate that models, but in Jupyter Notebook, where we can tweak the model a bit more if we want to. First, we run pip install sentence transformer. This is the package from Hugging Face. By running pip install, we have now pulled this package down into our notebook. After running that, we'll be importing two very important libraries from them: sentence transformer and util. We now define our model to be sentence transformer. We take the name flax-sentence-embedding, old dataset, version 4 miniLM-L6. In case you're wondering, that is the name initially from here. After taking that, we need to take our source sentences. Instead of the original "that is a very happy person" from the model itself, we've taken our own sentences. In this case, these are the sources that we have taken our sentences from. Going to each link, you will find the sentences right there. In this case, we have 8 sentences to run together. And we're trying to find the similarity between every 2 sentences. So it will be the first one and the second one, first one and the third one, and then second and the third one, and repeatedly for all of them. Now to do this, first of all, we have to encode all of our sentences. Encode allows us to transform the sentences into vectors of values based on whatever token, whatever calculations the model has. Those will become vectors that represent that sentences. And in mathematics, we calculate the similarity between vectors by calculating the cosine similarity, which is the angle between the vectors. The smaller the angle is, the closer the value of cosine similarity is to 1. So that means our value, the closer it is to 1, the more similar it is. the lower it is away from 1, approaching 0, the more difference they are. That also works in our case too, because we want our number to mimic the models, approaching 1 if it is similar, and approaching 0 if it is not similar. After we calculate our cosine similarity, we then start to attach each of those similarities to the sentence pairs that we have used to compare it with each other. By running this section of the code, it will match all the scores to the sentences. And finally, we just sort them out by the similarity scores. And finally, we print them out so that we can view them in a visual way on the computer. Here is the output. The Adam River Salmon Society sentences, and compared with the Watershed Watch Salmon Society. This one scores the highest of those point of 0.7083, 70%, almost 71% similarity between them. And it is ranked just like that, going down below, with our lowest one being lobster fishing halts as shopper buyers stop purchasing from harvesters. This is the news. And what you'll need for the best baked salmon. Lobster and salmon, very different topic. And also one is a news and the other one is a recipe. In this case, they try to aim towards different audience. Therefore, it is ground to believe that they are different from each other. And yes, our model also agrees on that, giving us only a 14.57% similarity between them. And that is it for the first example. It's purely just comparing two sentences and their similar score between each other. Next, we will go into example number 2, where we will be comparing all 7 sentences with one sentence at a time. With our second example, also using the same model and also using the same source, we can almost, the initial part of the codes from pip install to importing the packages in, they're all similar to each other, all the way until our sentences, with the only difference actually being right here, where after running our cosine similarity between each other, we will be seeing a appending, but only between cosine 0. Cosine similarity, first element, and the rest of the sentences. What this means is that we're comparing all of the following sentences to the first one. Our strategy stems from steep decline of many Pacific salmon populations, and so on. This allows us to run a more closer view on the similarity, where we see that Watershed Watch Salmon Society scores the highest at almost 0.5954, and our second one being very close from Sunshine Coast Salmonoid Enhancement Society, when our last one is actually still a lobster fishery holds, because it's about a different topic. This allows us to closely examine one sentence with all the other sentences without digging through everything like the previous example did. Next one, we'll be going over a different way of comparing our sentences by going through their topics, what they're focused on. And those topics and what they're focused on can actually be custom declared, where we don't have to follow certain conventions defined by the models. Next one will be called the zero-shot similarity.